Yeah.
Do I need a mic? Or?
Yeah.
Okay. So, good day everyone. My name is Markian Rizun and I'm from Ivan Franko National University, Ukraine. And I did this project in association with ERMOD team in Ria, so huge thanks to Camille Teruel, Gustavo Santos and Stefan Dukas. They helped a lot. Okay, so today I would like to present you a new pattern matching library that allows us to match and transform any objects in Pharo. Okay, let us get into it. So to begin with, pattern matching was originally introduced in functional languages, and the main use of it was, and still is, the inductive definitions of functions. So to explain myself, let me show you the example. Here we have a function written in Haskell. It returns an nth Fibonacci number, and to do that we have a fib, which is a pattern, and it matches an integer n, and depending on its value, a certain action is executed. So if n is equal to 0 or 1, 1 is returned by function, and otherwise the pattern matches recursively. So this is the use of pattern matching in functional programming. Later, pattern matching facilities were adapted to object-oriented world and integrated in a number of languages such as Newspeak and Scala. The main use of it is to decompose object data and find parts of interest, analyze them, etc. Currently in Pharo there is already an existing pattern matching facility, which is the rewrite engine. Maybe some of you are familiar with it. For example, Yuri Timchuk presented a match tool which is based on it. So the main use of it is source code rewriting, which means that it matches specific AST nodes, abstract syntax tree nodes, in Pharo. Here is an example of what we can do with rewrite engine. Let's say we have an input of the if true, if false statement, and would like to rewrite it into a max message send, which is a much better implementation of the same behavior. In order to do that, we should apply this rule of the rewrite engine, which is a pattern, to a source code. You don't have to understand everything that it says, but generally it is very similar to a Smalltalk code. It only introduces a few new symbols, such as backquote and add symbol. So the rewrite engine is a really great and effective tool for source code rewriting. We use it every day for code refactoring, etc. Moreover, it proposes to create patterns with a syntax that is very similar to Smalltalk code, as similar as possible. However, this engine has its limits. First of all, it is only possible to work with ASTs, so unfortunately you are not able to rewrite any other object than AST. Sometimes patterns can be confusing, so you do not always know the behavior of the pattern if you apply it to a certain AST. Also, patterns are not composable, so it's another downside. And during the matching process, if you debug it, it doesn't really provide you much of useful information, so it's not very user-friendly process. Also, if you, for example, inspect a pattern, you do not know, for example, which part matches which part of AST, and that is one of the reasons why Yuri implemented match tool. And unfortunately, for me, it is a major limit that it is not extendable. That is why we propose our solution to overcome these limits, forms a new pattern matching library that allows to match and transform any objects. And patterns in our library are first-class objects, so you operate them as usual with message sends, etc. You can inspect them and so on. So let me show you a few patterns from our library. First one is the simplest one. It's an equality pattern. It wraps an object and matches another object that is equal to the wrapped one. So here we have 1 equals. It's an equality pattern that would match any integer that is equal to 1, obviously. Then we have an AND pattern. It composes the number of different other patterns, and it successfully matches an object if each of this pattern, or rather sub-patterns, matches. And the same goes for OR pattern, but here one of the sub-patterns should match in order to the whole pattern succeeds. The main pattern in our library is a list pattern. It also is composed out of a number of other ones, and we use a comma to concatenate them. The main idea here is when the list matches an object, it deconstructs this object into smaller parts, and each of sub-patterns match one part of this deconstructed object. You will see later in the example. Also, we propose a nested list, which is basically the same as list pattern, just that one of the sub-patterns is another list pattern, so it allows to match objects with a deeper structure, such as, well, ASTs or other tree-structured objects. And also we propose a star list, which is also a list pattern, but one of its sub-patterns may be marked as star. It means that this sub-pattern may match any number of parts of the constructed object. So it will, in order for the whole pattern to match the object, this sub-pattern, P2 in this case, will match as few parts of the deconstructed object as possible to make the whole pattern succeed. Of course, we propose a rewriting pattern, which allows you to match and transform objects. So it is composed out of 2 parts: matching part, which is a pattern that matches an object, and then a transforming part. It is a block that creates new object. The block has 2 arguments: int, which is an object that is being matched, and context. It provides additional information, such as access to meta variables, which we can create using a named pattern. So a named pattern basically wraps another one and gives a name to a successful match, so you can later reference it as a meta variable in the transformation block. And also there is any pattern. It may be useful sometimes. It matches any object. So let's see how the matching works. It is very simple. You just send a match message to a pattern with an object as an argument that you would like to match. So for example, we have a list pattern which is composed out of 2 sub-patterns, and in line 2 we match it with a point. So what happens, the point is deconstructed into 2 integers, and these 2 integers are matched separately with the sub-patterns of a list pattern, as is highlighted by orange and green colors. So also you can match ASTs, so it doesn't matter what it is, the object actually. Here we also have a list pattern with 2 sub-patterns, first one any and the second equality. And we create an AST, which is an assignment, and then in line 4 we match this AST. So happens exactly the same thing. So the AST is deconstructed into 2 parts, variable and value, and then it matches separately each of sub-patterns of the list pattern. Of course, we propose rewriting besides from matching. So you just have to send a rewrite message to a rewriting pattern. And well, as I said before, rewriting pattern is composed out of 2 parts: match and transform. So, for example, here we have a matching part, which is again a list pattern, and a transforming, which is a block that returns a point with inverted coordinates. In order to do that, we use first argument of a block it. It refers to an object that we will match in line 5. So here we say it y and get an access to a coordinate of an object that we will match later. Then we compose this rewriting pattern and rewrite an object 1 and 2 and obviously get point 2 and 1. So this is a very simple example, but you can get a lot more complex transformations with our patterns. For example, as I shown before, ASTs, and it can go work with any object. So to summarize, our library is able to match and transform any objects. So is it a user-created or built-in Faro object, such as you have seen a point or an AST, you can basically rewrite anything. And also our patterns are first-class objects, so you can operate them as usual. You can also compose them with a number of predefined combinators that we can have in our library, and you can convert them from one type to another. The debugging process is very user-friendly. You have all the additional information that you may need, such as, for example, which part matched which part of an object, etc. And well, our library is easily extendable, so you are welcome actually to add your own types of patterns and maybe combinators, well, as you wish. But obviously, our library has its downsides. So first one is that we do not have a specific API for AST transformations. Therefore, the code of the patterns can become sometimes bulky if the AST itself is a big one. So that is for the future work. We plan to implement an extension for our library that would introduce probably a new kind of syntax for the AST rewriting. Yeah, and that is probably it. Thank you for your attention. Maybe there are any questions?
Any questions? Yeah.
Yeah, I was wondering how you match objects. Like in the example of points, it looked like you were matching the string output, but do you actually match the instance variables? Do you match them in the order they are declared in?
So what is behind the scenes, what I didn't show, it is we have a deconstruct method, which is defined in classes, for example point, and what it does is actually returns an array of variables, of instance variables of a point, x and y, and then in the matching we get this array and we match it with sub-patterns as it is in list.
Okay, so but that means you have to write your pattern to map this deconstruction correctly.
Yeah, so basically what you can do is implement this deconstruct as you wish, but we will of course implement all the basic objects such as point, association, AST, etc. In our library. So, but if you create a new object, a new class, yes, you have to implement this deconstruct method on your own. Any other questions?
Yeah. You have another? Yeah.
One application that I can see is that I have some kind of object graph and I want to find one specific object in that graph. Do you have any idea about how fast your solution performs on an object graph?
We only compared our solution in AST transformations compared to the rewrite engine, so it was practically the same as a rewrite engine. And I believe it should work pretty quickly.
I have one question. What is, how can you position your work with the one that you represented? I didn't follow the presentation, but
How can I position my work?
with Yuri's.
With Yuri.
Yeah, with what he has done with writing.
Well, this project is a bit step aside because it doesn't work with rewrite engine or anything. I just wanted to compare it, but I think that match tool won't be in any kind of connection with this, but maybe later we can cooperate and create new tools on top of this. So I think that's the idea, because we are building a base for future rewriting stuff, you know. And yes, I believe that we can cooperate later. Any other questions?
Okay,
Thank you.